Hi, have you ever been in a situation where you are in the debugger and you need to inspect a variable and you need to go really deep down in the stack or in the tree to see your value? Let me just show you. This is not a test. This is the real thing. So I'm just opening here and this is an STD variant. It's terrible in the debugger and I don't think it's the debugger's fault actually. And we're getting close now, and there is my value, 10,20. That was a lot of work. Stay tuned to see how you can get that 10,20 all the way at the top of that item foo. If you look at my debug output over here, you can see that size is printed as 100,200, while the foo variable is printed as, well, the address wherever it is in memory. The size is just a regular queue size. My foo variable is an instance of this super simple struct up here with an I and a j in. So why isn't foo printed more nicely? Well, how would QCreator know how to print it? Well, you can tell QCreator how to print it, and that's what we'll see in this episode. I have a daughter who just broke her wrist from being on her roller skaters. It goes down to me, why did I ever allow her? Why did I even teach her that? Well, as if I taught her, but why did I allow her? Had I just, well, she will have many hours of fun on those roller skaters. And that's the kind of warning that I want to give you here. What I'm going to teach you now will very likely make a huge difference in your debugging. Instead of needing to click your way down to the struct for a stud variant, you could just see the value up at the top. But it is going to be slightly frustrating. So I'll try and give you all the tools that I've learned. I've been playing with this for 3 days now in a row, and it has been rather frustrating, but I think that the end result is pretty good. So there you are. Now you have been warned. The very first thing you need to do is to go to Tools, Options, Debugger, Local and Expressions, and then browse your way down to a file, a Python file, Python personaltypes.py, and I suggest that you base it on the code that is in the description below, so you don't start entirely from scratch. That, however, is not going to cut it for you. You'd also want to Google a bit, and you want to find this page here, Creator Debugging Helpers. Scroll down a bit, see my scroll bar over here, to adding custom debug helpers. And down here, there's a comment telling you where could you place this file. So you have two options. You can either put it somewhere on your hard disk, possibly within your Git repository, and then just have your QCreator pick it up from there, or you can copy the files along the other debug helpers that comes with QCreator. However, you will need to find those other, and that's what I did here in my Kate here. You can see here is my personal files. That's the one that we're gonna see in this episode here. But in this directory, you will also find QTypes.py, which has the debug helpers for the built-in types in Qt. You'll need to look at dumper.py. That is the framework around this. And if you are on Linux, then GDB Bridge, or if you are on Mac, then there is on Windows, whatever, Bridge. And finally on Mac, there is LLDB Bridge somewhere along here. You can find it better than me. You'll need to look at that too. That's more or less the implementation. These two files, or these three files, is super good at getting inspiration from and simply trying to read up on what is going on, but I'll tell you most of this. So let's assume that we have this now, and then we can continue on. Okay, let's take it a step at a time. First of all, to be able to print a custom type, I need to create a Python function. The Python function is called qdump __, the namespace __, the class or the struct name not dot anymore. That's the name of the function. My foo that we saw here in my QCreator, as let's just close this down. The foo is just a struct without any namespace, so therefore it is called, there we are. So therefore it is called qdump underscore foo, and then it takes two parameters, d and value. D is a dumper. The dumper is the data structure that we need to interact with to build up the result. And value is the actual value from the underlying GDB or CCDB or whatever that we're trying to print. Let's start out with a very simple setup here. The very simple setup says I equal to, and then I can simply brace or use the square bracket to get into the actual value here. So the value is I. And if we look over here in my debugger again, we can see that I had my foo that had an int I and int j. And simply, let me just take that away. Simply by using the bracket here, I can get into the I and the j value, and that will give me an item from the debugger. It contains information like what is the type, what is the actual value, encoded in one way or the other. That I cannot use very easily, but what I can do with it is that I can go and ask for the integer value from it. I can get integer values, and that's approximately how far I got. Even getting a string, a regular Q string out from it to be a JavaScript string was beyond what I could do. But in most cases, you actually just want to take whatever value and massage it in one way or the other, where you do not need to do what I do here. But in any case, let's see what I got. So I got the integer picked out here, the I and the j, and then I put them together using this syntax here. And if you're new to Python, well, don't worry. It's basically just the QString arc that I'm doing here, the %d, and then I and j coming in here. And what I do is that I call d.putValue. So d is the engine that I got up here, the dumper, I think it is called, dumper.putValue, and then this string. And now I'll save it. I'll go back to my debugger. I'll stop my debugger here, and I'll start it again, and I'll hit this breakpoint again. And now you can see my foo is printed as 10,20. Yeah, I hear you. You don't want to restart the debugger every time. Don't worry, I'll show you how to avoid that. So what you need to do is to go to views, you need to find views, and then you go down here and choose debugger log. That brings up that stuff up here. And this is the first pleasant surprise that I'm giving you, because it took me 2 days before I realized what this button down here does. I'll show you. But in any case, when you are up here, now right click and choose reload debug helpers, and that will reload them. And if you have an error, you will click on this one. It will rerun the debug helper or rerun the most recent command, and then it will show the error up here. What you see currently is really just a garbage, but we'll dive back into that in a while to get an idea for what that is. Let's go back to the file here and extend that a bit. So if we go over here again, you'll notice that size, when I open it up, I can actually see the width and the height in there. And now I can't see that. So if I had more data that I really wanted to see, then I could add them there. And let me show you how we do that. So taking this whole code here and just commenting it in, it'll look like this. So let's just try and run it. I save, I go over here, up here, right click, and reload debug helpers. And if you are on a brand new version of Qt Creator that might have just come out when you watch this, there's actually a shortcut for that now, but that was just added yesterday, so it's not in my version yet. But what you see now here is that my foo actually has j and I, and it even has a sum of those two. For whatever reason, I wanted that in my debug helper, and that's what we're doing over here. So first thing, d.putExpandable. D, that's our debugging helper again. I say, hey, this item can actually be opened. That is what brought us this arrow down up here that I can use to open and close it. Also, if d.isExpanded, so this code down here is only executed if I actually open the element. What I do then is say d.putSubitem. No, first I do with children d. So with children D is actually using a pretty fancy thing inside of Python, where you can have something that feels a bit like a constructor and destructor executing. And so with children D, you can go and look. There's a class in the dumper.py that is called children. With children D, I do the following things. And what I do is I call put sub item j. So I'm putting the j variable here, value j. So it's just the value that I have up here. That's cool. Remember, I have the item type. That's the thing that contains the type and the value and some debugger stuff. And then there is the JavaScript. I've been doing too much QML. There's the Python variable that is called j up here. So that's the integer in Python. But what the put sub item takes is this item element over here. So if you had the I and you wanted to put it in, could you do that? That needed me asking a bit on the Qt Creator RSC channel if anybody could help me, and I found this code here which made me like shiver and get sweat and whatnot. So do not try this at home. And so what it does is that it's the put sub item, but the tricky part is to get my integer into be a debugger level item again. And it does so by create value. It needs to take the integer and pack it. And the I here is not the I. That means that I pack it as an integer. I need to provide a type for the underlying thing, which I do like here. So I would never, ever write this code here. If I needed to do this, what I can do is that I can do with sub item. So with sub item, it's just like with children where there's a bit of constructor and destructor being executed. So something before and something after. And what it does here is it uses a put value. Notice put sub item and is taking an item up here. But up here in the first part, I did just put value. That's the one that takes a value, not an item. So put value, I can do that with the sub item. The sub item is called sum and the value is I plus j. And if I even want to, I can specify the type, but even this line isn't needed. So the result of all this is that I now have I, j, and the sum of the two specified over there. Before we move on, I'd have to tell you a bit about that little button down there and look at the backtrace. It took me 2 days with this before I realized what that button did. So man, that was a very frustrating 2 days because all I ever got was access denied. That was the only error message I could get back. But let me show you what it looks like. Let me introduce an error. The error is just forgetting the D here. Anybody could do that, right? Well, I did at least. Let's save that. Let's go back into Qt Creator, right click, reload configuration, and my foo now doesn't have anything. And here is the not accessible. Whew, that was frustrating. So what we'll do, escape a few times to make this go away, make this slightly larger, and then press this button over here, which will execute the last executed debugging command. And this time it will actually allow exception being thrown on the Python side to show up on your screen. And that's what we see here. We can see it caught an exception in sub item. And here you can see down where it was called and missing one required positional argument D to whatever I was calling there. That makes it completely much easier to figure out what's going on. Another little trick that I did is to go over here and simply print out my values. So if I got something back here, I'm looking at what does that look like? Well, what I can do is simply print out, and I like doing something like this so I can actually identify where it was printed out. And this is a regular Python after all, so I can print out the value here and see what does it look like. And just imagine that I wanted to look at what this little fellow looked like rather than the actual I. Then I could do it like this, save it back over into my Qt Creator, reload, debug, and you can see my lots of equal signs, and here is the value, name, I, type, int, and all those additional things that I told you that the item class has. What do you say? Yeah, I know, nothing over here. That's because the printing out here actually confuses. So every time you print something out like this, it will not show anything over there. But the good thing is that as soon as I nuke my print outline here, whoops, like this, nuke them again, hopefully, right click, reload debug helpers, and we're back. The previous example had one problem. I wanted to show the content of my struct together with a pretty printed version of my struct. But imagine that I added a variable in my struct and I forgot to add it in my pretty printer, then I couldn't see it. And of course, at the time when I realized this, I had forgotten everything about how my pretty printers actually worked. So there is a nice trick to avoid that. Let me show you. What you can see here in part 2 is that I have a namespace. Inside there I have a struct and a few variables here. And my namespace, I just create an instance of it here and have a breakpoint at it. And let's see what it looks like when I get to that namespace. You can see up here, well, not much. Right click, reload. And now it says secret, but I can open it up and I can see the variables underneath. And how did I do that? Well, I simply use this. So this is the put value saying secret here, and then d.put plain children value. That's the one that will put all the children of that variable underneath here. So if I one day add another variable to my struct, it will show up there without me actually modifying the debug helpers. I did give you the warning. I don't know everything about this, didn't I? What I would like to do in this episode is to give you some practical examples from my own doing that will give you hopefully enough that you can actually apply this to your own code base. And the next one I'm going to show you is how to pretty print a simple data structure, money. We've seen this in previous episodes. Money is a currency and it's an amount. Here you can see the money class. As I said, there's a currency and an amount. And I already applied the code for pretty printing this, so you can see it says euro 100 over here. And it comes from this example. I'm creating an instance of money, 100 euros. And that's what we see over here. Now I can still open it up to see the variables inside it. The code for this looks like this. So I'm going here and fetching the amount as a floating point. I'm fetching the currency, that was the enum, as an integer. And then I do this Python magic here, where I simply do the equivalent of QString arg, where I concatenate that if the currency is 0, that's the enum value for euro, then it's EUR. I actually did try with the euro sign, but I got some encoding wrong here. Otherwise, if it's dollars, then otherwise it's dollars. And had there been more currencies, this would of course have been more complex. And then again, put plain children to make sure that I can open up and see the children in case I want to debug further. Yes, I did not handle the case very well for the empty money. Let's try and create one of these and see what happens. Hopefully, because I haven't tried this, hopefully the universe is not going to be imploding. If it does, it was good meeting you. In the meantime, I'm recompiling and I'm lots of warnings because I create all these variables I never use. And here is my M1 isn't even printed out. And I'll bet you if I click over here and I make this bigger, there will be something complaining about maybe, maybe not, but I definitely did not handle my null case very well. And here comes the warning sign. Again, I talked to some of the people who actually implemented QCreator about the way that I did this, and they said, no, you should be printing your money out exactly like you do there, not with the thing that you did that I'm going to show you now. See, I do understand where they're coming from. First of all, what I'm going to show you now will not work if you debug a core file. Second, it might be slower, and that might be super annoying if you break lots and lots and lots of times and it needs to take a second to print a money value. For me, I couldn't care less about that 1 second, even if it was 5 seconds. When I'm debugging, I want my values to be correct, not to be fast. And correct here means that I do not want to rely on my debugging helper being exactly up to date with what the code base is. Imagine that I had introduced a new currency and I just had the previous version saying if it's zero, then euro, otherwise dollars, and now I have British pound. I would hate to have it show up in dollar and debug and debug and debug just to realize, oh, my debug helper actually printed out the wrong thing. So what I'm going to show you now, and still the warning sign, I'll show you how you can actually call into the C++ code to get it to pretty print. Because in there, you likely would have got a warning saying, hey, you forgot to actually handle the case of the new currency. So let's see what that looks like. The new part that I'm going to show you, the new version of qdump_money looks like this. And I'm not going to go into super many details with it because I don't understand it all that well. It is a result of tinkering around for a while. But what you can see here is that I call, no pun intended, I call a method called call, d.call. And what it takes is the value and it will call a method on that value. So in my debugger, I have an instance of a money. And now I will call toString on that instance. And what that returns is actually a QString. And that's what I'm specifying here. And I take that string when I get that back into that was the value type over here in my debugger. I can put that right in there and then put plain children again. And let's save this. Let's go to my debugger and reload the debug helper. As you can see that it changed to euro sign now, 100,00. And what I had here on my money class for all of this to work is that I have this toString method that can actually print it out. Yes, it might be slower, but hey, now I can pretty print more or less any of my data types. Just add a QString, add these 3 lines of code, and I don't need to bother about trying to figure out, well, the parts, these 3 lines of code. I don't need to figure out how to get the values in and massage them. These 3 lines with a toString works on pretty much every type. Personally, I added that in KDAViewer to 20 different types. Once I got this working, it was super duper easy. Cut. No, not haircut. Come on. Oh well. So the variable that I wanted to print out, I could add a method print to that, but what if I can't modify it? Remember the variant at the very beginning of this presentation? Well, I couldn't add it to variant because I don't think that Bjarne Stroustrup would allow me to add a print method there. But I can do it with a global function. Let me show you. Let's just meditate for a second on the expansion over here on the right in my local variables view. It's a foo or a bar. That's what I have here. My using foo or bar is a std variant of foo or bar. Foo and bar are very simple structs. So either I have a foo or a bar, and as you can see down here in my instantiation, I have a foo here, I have a bar there, and well, this is what it looks like. I expanded the foo, and you can see all the way deep in its stomach, I have an I or a J. Had I just had a C++ method, which I do now, I could print it out pretty simple. If I hold the alternative foo, then return the string foo, parenthesis open, and then just the to variable. And if it's a bar, just bar and the to variable. And I already did change my code, so let me just reload my debug helper here now. And I still have the ability to see all the children, as you could see, but notice now it says foo 10,20 and bar high, well, missing parenthesis. Seems that's down here on me. There's my parenthesis. And let's see what that looks like in my Python code. So what I do is that I call a method called parse and evaluate. And that one actually calls onto the C++ part order. It uses a debugger to execute the code. And what it calls is the foo or bar method. And it takes one parameter, which is this foo or bar, the value that I have. And yeah, it's terrible here. What I do is that I take my address of that, because that's what I have in my debugger. I take the address of that and I cast it to a foo or bar pointer, and then I dereference that so that I have a foo or bar instance, which I call onto the foo or bar. The result is a string, it's a QString, and I simply say put string value with my string onto this D, my dumper, and finally put plain children again so that I do have the option in my debugger. If it's like, really, that looks weird, I can always open up and look at the correct value in there. That was nice, even with a haircut. So the last piece I'm going to show you is really from production in KDAP. I have a list of employees, but instead of it being full-blown employee objects, it is really just a user ID. We have them in a database, I read them in. And for years, I've been looking at 10, 20, 315 or whatever the user IDs were, and I had to look up if I really needed to know who they were. I would love in my debugger to see the names, and now with this small endeavor of looking into this, I can. Let me show you the code for this. Over here on the left, you can see what it looks like. A is 1 and list is 1 and 2. The code comes from part 6. I have a user ID A, which is 1, and I have a user ID list of 1 and 2. And user ID and user ID list are just regular using user ID int. Using user ID list is a queue list of user ID. So can I do that better? And yes, I already told you that I could. Let me show you what it looks like when I just reload here. And now you can see that my user number 1 was actually David Gahan, and my list is David Gahan and Martin Gore, and you don't get bonus points for knowing who these gentlemen are because I've told you in so many episodes. I'm a huge Depeche Mode fan. It looks like this. Let's go back to the C++ code first. So I have an employee database somewhere. I can get to my employee database using the static method called instance, and on the employee database, I can look up a user ID to the name, so it returns a queue string, look up with this user ID here, and it returns. And if it's, and yes, Rick Astley was not part of Depeche Mode. Still make good music in the zeros, but that's a different thing. You can see I print out actually in my result, go away, application output. You can see that it prints David Gahan here. That's because that I had the qdebug employee database : instant lookup A. And that was the David Gahan you also saw in my debugger over here. What does the code look like? First, and this is the part that I couldn't figure out myself, so I got a bit of help from the IRC channel. But first, I have my lookup of the user ID. My value is, I take it as an integer. I call parse and evaluate here on employee database. That's just like we did up there. Employee database instance lookup of this employee, and I put this in as a string. Awesome. That is really saving my day. And now for the list. Unfortunately, there was a bit of problem when I had it as a list because it didn't recognize it as integers in there. So I just needed to write create type def type. And what that does is, and then I call format, and then finally I just put the item of the list of user ID. What? Yeah, I know I was mumbling just a bit. I had no idea what that code does, but I could, had I had the ability and more likely the attention span. I could have went to Dumper and I could have went to Qt Python and so on and looked into details of what they did there. But I didn't. So fortunately, I had a bit of help with friends, but just as an ending thing here, enjoy the beauty of being able to actually see the usernames rather than just or the employee names, whatever, instead of just looking at their employee IDs. Thank you for walking these dirty roads with me of trying to figure out how you can actually get these debug helpers working. I think it's actually worthwhile. I didn't try, but the documentation claimed that it's okay, so they should be working on Windows, Mac, and on Linux now. Of course, in my final project, I also had some installation of getting them in the right place and so on, but I'll let you figure out those details on your own. Please do subscribe to our channel. Please give me a thumbs up for the haircut or whatever reason you want to give me a thumbs up. And please do leave your own debugging helpers in the comment section below. I would be really interested in seeing what other people would come up with of fancy things. Maybe we can actually learn from each other. I'm Jesper Petersen. You've been watching another episode of Qt Widgets and More. Stay tuned for many more to come. And until then, have a great day.